Okay, so my slides are visible, right?
Yes, it's visible.
Okay. So let's wait 5-10 minutes and allow other people to join. In the meantime, I just want to introduce myself. So myself, just a minute. So myself, Shresh Gupta, and I'm a PMRF scholar at ISA Kolkata, and I am your TA for this course. The course is the course ID is NON23-MM10. The course name is Solar Photovoltaics Principles, Technologies and Materials. It has been taken by Professor Ashish Garg from IIT Kanpur. So, this is a TAship class, and the main motto of the TAship is to clear out the doubt sessions and basically to help you out in order to solve the your assignments. So, I have taken around 10 questions based on your week 1 classes, and I will be showing you the question and asking you if you can solve it, and if you cannot solve it, I'll show you the solution also, and I'll share you the PDF of the solution too. So they are my question slides. If you can see, just for the sake of seeing, I have 10 questions around. Okay, and I have the solutions of all of them. So I have the solution of all of them in PDF format, you can see, and I'll share this file with you guys. So I'll share this file also with you, and you all are free to send me an email anytime on my email ID if you have any doubt. So let us start at 3:10 p.m. Okay.
Sure.
So just to by the time others are joining, let us try to actually find out the importance. So as we all know that what is the importance of solar energy, like why this course is important and what will be the advantage of this course. So I hope you all are the science students or related to the engineering background who are planning to do research or planning to do some work in future related to solar energy. Okay, so I myself work on solar energy. I do research on perovskite solar cells, and I try to use another impact of the solar energy for like photocatalysis and all of this. So like you know that the world conflict is going on, and we need to have some alternative sources of energy, and there could not be any other source which is more feasible, viable and available, and can supply with such a huge and tremendous amount of our requirement. So in order to entertain the same regard, this course has been designed, and it will really help you out to understand the basics of solar cells, its different generations, how this solar energy can be converted into electrical energy, the different domains, the different layouts of it, and if you are in the very beginning of your career, it will really help you out to shape your career, like what should you work upon, and how what could be the possible fields you can work upon, the area of research and all these things. So like I would suggest take proper interest, and feel free to email me anytime if you have any kind of doubt. And basically if I should say about the classes, sir has divided the classes into 7 or 8 weeks. So in the first week, so basically there is this introduction and the fundamentals. The actual classes and the actual things start from the third and fourth weeks, where they're talking about the carrier temperature and junctions and the essential characteristic of photovoltaics. So if you really want to learn something from this course, I suggest you to really take attend all the classes of especially from week 3. If you have missed in the beginning, feel free to contact me, but do attend the classes from week 3 to week 8. It will really help you out to give you a final layout, like how like people are working on this solar energy and trying to harvest this solar energy for completing their needs of energy in the domains. Okay, so like we know that sir has already if I should show you the slides, sir's lectures. Yeah, people are joining up. 2 more minutes we are waiting for all of them, and then we can start with our assignments. So in the lecture one, if we can see, uh, uh, the sir actually started with this solar photovoltaics. So what is the importance of photovoltaics? Photo plus voltaics, that means light, the solar energy. Okay, the principles, technology and materials. So basically sir has divided it into 40 lectures. The week 1 and week 2 and week 3 are the basics. The actual things start from the week 3, and then from week 4, week 5, week 6, week 7 and week 8 you can come to know about the areas in which the research is going on nowadays. Okay, I hope you all are from either science and engineering background, and I wish that you all are going wishing forward to go into research domains. Okay, so without delaying further, I think we are open up with the time. How many people have joined? Around 10 people have joined. Okay, so 1 more minute we are waiting, and then we can straight away start with our questions. I'm audible, right? Everybody is able to hear me and see the slides, whatever I'm sharing?
Yes, yes, you are
Okay,
audible and we can see you. We see the
great,
slides also.
great. Okay, so let's start. So basically, I'm introducing myself once again. Myself, Shresh Gupta. I'm a PMRF scholar at IISER Kolkata. It is Indian Institute of Science, Education and Research. It is one of the sister of IISc, Indian Institute of Sciences. In order to flourish the science research in India, MHRD has opened certain ISERs, and ISER Kolkata is one amongst them. So like you are free to email me anytime whatever doubt you have about the classes, and you can even write in the chat box. And like this is the very first class, so I'm just trying to give you a general introduction, and then we can figure out how it goes out. Okay, so in this assignment 1 that I have made questions on the basis of our first week classes, and I will be showing you questions first of all, and then you can tell what answer it could be according to you, and then I can show you the solution. I will be making a recording, and that recording will be shared in my YouTube channel, and I'll also share the PDF of the slides as well as the solutions in the drive to you people, and you're always free to email me anytime you want. Okay, so without delaying any further, let us start. So the first question is the correct relation between angle of elevation theta, zenith angle theta z, and the solar azimuthal angle gamma s is. And I ask you people to tell me what could be the solution. What amongst the 4 options is the right could be the right answer?
Is it C?
C. Okay. Others? Ashish, Abin, Gaurav, Rajiv, Suraj, Tanveer, Vinayak. What do you think? What could be the right answer? Sir has taught this, right? You can type in the chat box. like we need to make it very interactive. Okay, see, seems like you guys have attended the classes very well. Okay, so okay, so yeah, the right answer is actually C. And if somebody of have you missed the class, let me show you the solution. So basically, with definition, if we talk about the elevation angle, I'm talking about the three things: the angle of elevation, the zenith angle, and the solar azimuthal angle. So what is an elevation angle? Okay, so the elevation angle, it is also used interchangeably as altitude angle, is the angular height of the sun in the sky measured from the horizontal. Okay, confusingly, both altitude and elevation are used to describe the height in meters above sea level. The elevation is 0 degree at sunrise and 90 degree when the sun is directly overhead. That means directly overhead. Okay, you can see it happens at the equator as well as equinoxes. So the elevation varies throughout the day, and it also depends on the latitude and a particular location. To clarify the same thing, let's have a look over this figure. I think yesterday Ravi has talked to you about a website which is pveducation.org. So you can find even detail about all these things on that website if you want. But just for the clarification of doubt, we see this is the point of sunrise or sunset. Okay, and at sunrise or sunset the elevation angle is 0 degree, and the maximum elevation angle is at the noon time when the sun is directly above us. Okay, now what is an azimuthal angle? The azimuthal angle is a compass direction from which the sunlight is coming. At solar noon, the sun is always directly south in the northern hemisphere and directly north in the southern hemisphere. The azimuthal angle varies throughout the day as shown in the animation below. At the equinoxes, the sun rises directly east and sets directly west regardless of the latitude, thus making the azimuthal angle 90 degree at sunrise and 270 degree at sunset. In general, however, the azimuthal angle varies with the latitude and the time of the year and the full. So if I show you the figure for the azimuthal angle, you see this is the northern hemisphere, this is the southern hemisphere, this is the western, this is eastern, and if you talk about azimuthal angle at the solar noon, it is 0 degree. Okay, and if we see like this is how the azimuthal angle is actually calculated. Now the last thing was the zenith angle. Okay, so if I talk about the zenith angle is the zenith angle of the sun, which is the angle between the sun's rays and the vertical direction. Okay, so it is a complement to the solar latitude or solar elevation, which is the altitude angle or the elevation angle between the sun's rays and the horizontal plane. So at solar noon, the zenith angle is at minimum and is equal to the latitude minus solar declination angle. This is the basis by which ancient mariners, this is very interesting, that's why I added this line here, and I'm repeating again, I will be sharing all these PDF with you so that you can read it whenever you feel and you can ask me whatever doubt you have. This is the basis by which the ancient mariners navigated the oceans. Solar zenith angle is normally used in combination with the solar azimuth angle to determine the position of the sun as observed from a given location on the surface of the earth. So what happens, the mariners are there when they're traveling in the ocean. They don't have, like, initially they were not this wireless connectivity or the satellite phones, so they used to find the directions and tell about the exact time or guess the exact time or tell their locations on the basis of these angles. That is the importance of solar zenith angle and azimuthal angle and all this. In order to summarize, I have also added this PDF picture from one of our textbook, which is clearly showing the relation between theta z, theta s and gamma s. This is the northern hemisphere, this is southern hemisphere, this is eastern, this is western. You can see the sun is here. If you directly make a perpendicular line from here and do it from here, then this is your theta s, which is the elevation angle. Okay, gamma s is the actually azimuthal angle, and theta z is the zenith angle. Okay, and other parameters are also there. We can know that the delta is a declination angle. Sir has already told about this. Phi is a latitude, n is the length of the day in hours, omega is the hour angle, and these three are where we are considered about. So we had to find out the relation between theta s and theta z. So if we take the theta z here and take theta s here, theta z equal to pi by 2 minus theta s. That means our right answer is C option, theta z equal to 90 degree minus theta. So the question was the correct relation between the angle of elevation, zenith angle and the solar azimuthal angle. The right option is C. So you all are right. Good. Okay, let's move to the second question. The second question is saying the value of solar declination angle on a winter solstice is, and the options are plus 23.45 degree, minus 23.45 degree, 0 degree, 33.25 degree and 16.25 degree. And you can tell your answers. Type in the chat box if you are not comfortable in speaking up, but let's make this class more interactive.
Yeah, the answer is A.
Okay. Others?
The answer is B, minus 23.45.
You're able to see the slides, right?
Yes, we are able to see it.
Okay. Other people? Suraj said number B.
Yeah, for winter it is minus, yes, correct.
Yeah, good. Yeah, great, right. Winter, that was actually selling point of this question. Like we have to
Yeah,
understand the difference in between winter solstice and
yeah.
summer solstice. So Vinayak said V, Rajiv said V, and okay, and others. Ashish, Ashish said A, and
Yeah, it's B because in the question paper I think it is for the summer.
hmm, 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 hmm.
In the assignment it was summer and this one.
Okay. Suraj said A. Okay, fine. So let's go to the answer without delay. I'll be sharing this PDF. Okay. So right, let's hide the other question. So what is the winter solstice? It is also called the hibernal solstice. Okay, it is a hibernation period. Actually, for the polar bears. So when does it occur? It occurs when either of the Earth's pole reaches its maximum tilt. That is, it is away from the sun. Like that is a very frozen region, and when it is away from the sun, it will be more cold. This happens twice in a year in each hemisphere, one at the northern side, one at the southern side. For that hemisphere, the winter solstice is a day which the shortest period of the daylight and the longest night of the year, when the sun is at the lowest daily maximum elevation in the sky. So either the pole experiences continuous darkness or the twilight around in this winter solstice. So the opposite event is the summer solstice, okay? And during the December solstice is marked in between December 20 to 23, and solar declination is about 23.5 degrees south the Tropic of Capricorn. Solstices are shifting solar declination are a result of Earth's 23.5 degree axial tilt, and as it is summer, we know the sign marking as Saras told in the class. So the winter solstice will be minus 23.45 degree. The correct answer is V. So good, those who have answered, and those who have not, who got this doubt in between summer and winter solstice and putting this plus and minus sign. That's why I put it these two options. Putting this plus and minus sign can go through the week 2 class where Sir has told about which is plus and which is minus. Okay. Now let's go to the third question. The third question is saying the local time and the local solar time are different due to.
Yeah, its answer is I think A.
Okay. Who is this? Who is speaking up?
My name is Ashish.
Great Ashish. You're doing well. You're really doing well. Others?
Sir, the question is not visible.
Oh, sorry. Let me show you again. This is the question. Local time and a local solar time.
A, sir.
I expect all of the members who have joined to at least type in the chat box the answers. Vinayak saying C, Arvind is saying A, okay, okay. Somebody joined right now. Who is the one who joined right now? I think Chalakanu Jagan. Chalakanu, do you know the answer of this question? The question number 3. Local time and local solar time are different due to? You can type in the chat box if you want. Chalakanu, you there? Krishna, you know the answer? Let me have a look over it. Don't worry, like as this was a theoretical class, I am not taking this on the iPad. But from next week, I will be taking, from next to next, I will be taking it on the iPad. I will be writing up here. But as we are just solving assignment, there is not much to teach. So I made the slides. Anybody else who want to answer this question number 3? I'm repeating again. The question is local time and the local solar time are different due to. The options are Earth's orbital eccentricity only, which seems a very feasible option. Second is presence of different time zones. This also looks right. Both Earth's orbital eccentricity and presence of time zones, or the rotation of Earth around the sun. Like, do you guys really think the rotation of Earth around the sun is somewhere responsible for the difference in local and the local solar time? Like, what is the right option of this question according to you people? The people who have joined right now, I expect them to answer this. These all recordings will be uploaded, and I think people will consider it. Okay, so I expect you all to answer. The people who have joined right now, please type their answers in the chat box. Okay, fine. So we are going to the answer. So the answer is, you can see the third question. The third question is the local time and the local solar time are different due to. Before that, we need to know what is local time and what is local solar time. Sir has already taught, but those who have not attended the class or have missed out, I am revising for them. The 12 noon local solar time is defined when the sun is highest in the sky. Okay. So local time usually varies from local solar time because of the eccentricity of the Earth's orbit and because of the human adjustments such as time zones and daylight savings. You know, like this Greenwich Mean Time, or this like this these the timelines or the zones which are passing through different tropics or the equator, and the places which have different time. Okay, how this time is decided and how it is responsible on the local solar time. Let's see. So solar time can be divided into two things, like two parts. One is a local solar time, the other is a local time. The local solar time is defined when the sun is highest in the sky. That is, it is farthest, okay? And the local time, it varies from the local solar time because of the eccentricity of the Earth's orbit and because of the human adjustments. And the human adjustments are what? They are the time zones. So we have this option C, which is showing the both the Earth's orbital eccentricity and the presence of time zones. They are responsible for difference in the local time and the local solar time. Is it clear?
Yes, sir.
Yeah,
Yes, it's clear now.
yeah,
Yes, sir.
Abin, you're right. C is the right answer. So let's go to the fourth question. I mean, I don't want to make the class look boring. I mean, see, the introduction class, it is a solar photovoltaics. It may have some basic things and somewhat more theoretical concepts. You may not be getting to know a lot of new things. But as this is the first week of the class, so you cannot expect a lot of new knowledge in the first week. But as we'll move further, as we will move to the fundamentals of semiconductors, and when the Venn diagrams will start coming, type of different semiconductors, and these junctions, and then the generations of solar cells. This will get very much interesting. If you are really interested in material chemistry, and in material chemistry, if you really want to like do some work in solar related fields, trust me, this course is going to tell you a lot about the basics of solar energy, and especially the different generations of solar cells. I myself work upon perovskite solar cell. You guys can see this is a globe box behind me, which in which people synthesize a solar cell. Okay, like we make the solar cell and then we do the measurements. And let me tell you, just for the knowledge of you guys, like if like I should give some more information regardless of the course also. So this solar energy is not only utilized for harvesting the solar cell or other things. You know, people are doing photocatalysis also by the solar energy, and this photocatalysis means doing catalysis in presence of light. What do we do here? We make certain materials on the and we make materials on the basis of some understanding. What understanding do we need to have? We need to have the understanding of their band gaps. We need to have the alignments of their bands, the stability, and the electron carrier dynamics amongst them. And then we illuminate them in the light, okay, and then we put some CO2 over them. Okay, if I am talking about photocatalysis has many parts. In photocatalysis also, the most selling part today is CO2 reduction. Why do we want to reduce CO2? Because global warming is happening, CO2 is continuously increasing, and if we are able to reduce this CO2 and convert it into some usable forms, that is good for us. So people are trying to reduce this CO2 into usable forms, and the instrument which we use for finding out is this GC, gas chromatographer. In this, what we do, like we illuminate the gas and we put the photocatalysis, we illuminate it, and then whatever product we make, that means we are, with the presence of solar light, we are reducing CO2 into the usual forms like formic acid, ethanol, which has a direct use in the industries. So you can see that the material field and this solar, especially the solar field, has so many aspects. Like you can do research on it, you can find jobs related to it, and trust me, the future will be solar. The future will be solar. Like you can see, like Tesla is looking forward for making electric cars. Okay, and now if electric cars will be there on the road, or like hydrogen will be used as a fuel, even the hydrogen will be used as a fuel, then we need, like if we are using electric car, in order to charge the battery we need energy. From where this energy need will be fulfilled? We need some source, right? So we have to think about it. Even for the using hydrogen as a fuel, okay, fine. From where we are bringing the hydrogen, we need to split the water. We need to split the water. That means we need to split H2O into H2 and O2. Who will do that job for us? Hydrogen can be used as a fuel. There comes the answer: the solar energy. Everywhere the solar energy can be used. Like in Hindu mythology, we even respect the sun as God. Why? Because it is an enormous amount of energy where fusion and fission is happening continuously, and it is just giving us a whole amount of energy. What we have to do, we have to figure out, we have to use our knowledge, our talent, to find different ways of utilizing this form of energy. So this is the importance, and to understand the same, this course has been designed, and you people are expected. By this course you may know some basics, you may get to know some understanding, and you can do some research in future in the same field. Okay, so without delaying further, let's move to the next question. So the next question is, what is the value of equation of time in minutes for a location in Warangal on 17.97 degree north and 79.59 degree Eastern on May 15th, 2022. I'm not using 23, I'm repeating again. What is the value of equation of time for a location in Warangal, which is situated as 17.97 degree north and 79.59 degree east on May 15th, 2022? The options are A plus 3.76, B plus 4.66, C minus 3.45, D is minus 8.85, and E is plus 4.05. You guys have, I guess it's 3:33. You guys have 3 minutes to answer this question. You can write your options in the chat box by 3:36. Ashish, you there? Try to solve this question.
The day is, I think, 135.
Sir, 3.76.
The value of B is 133.15.
3.76.
Okay. Who is this?
Sir, Suraj.
Suraj. Okay. Others try to answer.
The 9.11.
Okay. Vinayak is saying need to know how to solve this. Yes, you will be told. Sir has told you about the equation of time in the class. I think week 3 or week 4. I mean third or fourth lecture. But I'll show you the solution, Vinayak, and I'll share the solution also. And if you want, I can give you other numericals. And if you still feel any doubt, you can email me afterwards. I have shared you the email. I will again write here, but you can email me afterwards. We are still having 1 minute. Those who are giving a try can give a try. Okay, so it is 3:36. Let's see the solution. So the question 4 is saying that what is the value of equation of time in minutes for a location in Warangal, which is 17.97 degree north and 79.59 degree east on May 15th, 2022. So the options were plus 3.76, plus 4.66, minus 3.45, minus 8.85, and plus 4.05. Okay, so we know the formula of equation of time. So we see that EOT is equals to 9.87 sine 2b minus 7.53 cos b minus 1.5 sine b minima. Okay, before going to this, let me show you this. Okay, this is a formula sheet, and I will share this formula sheet in which everything is written, and there are certain formula from where you can see what is the formula of equation of time. Okay, and sir has also told about the equation of time in the class, and there are different coefficient which are used for equation of time calculation, a, b, c, d, and generally we consider till a, b, or at most at c. Okay, are you able to see this? This is
Yes.
this is a solar sheet formula that has been prepared. This is a concise of single page of all the formulas that will be utilized at least for the week 1 classes, or in fact you are not having much numericals afterwards. So like this is the formula for the time related numericals. where you can see TS is a solar time, this relation is there, delta T EOT, which is equation of time, A, B and C parameters are there, where A, B, C are the coefficients of the EOT, and how they are found, sir has already told. Still you want, you can mail me, I can share you the video recording of my answer. Anytime you are free to email me 24 into 7, I will tell you the answer within 24 hours, okay? And the coefficients used are A, B and C, D. Generally we consider the first C. Now let's go to the solution. So the equation of time is this. So it has given 17.97 degree north and 79.59 degree east. How they have calculated this number of days? B is equals to 360 by 365 and minus 81. Okay. So number of days being calculated as 31 plus 28 plus 31 plus 30 plus 15, which are 35. Okay. So B will be 360 by 365 bracket 135 minus 81, which is 53.26. So 2B will be twice of this, that is 106.52. So if we put all these parameters in this equation of time, which has already been shown to you, what how this equation came. Suchi, okay. Hello Suchi. My ID is sd19ip011 @isercoal.ac.in. Suchi, why did you join late? You should join on time. You missed the starting 4 questions. Okay, so we are discussing this question. Okay, what is the value of equation of time for a location in Warangal? The latitude and longitudes are given as 17.97 degree north and 79.59 degree east on May 15, 2022. So till May 15th, how many number of days are there? We calculated. This formula I have already shown, and how this came, sir has already told. We calculated the value of B, and the B is this, that means 2B will be this. We put it this value in the formula, and after putting this value in the formula, you can see the equation of time will be 9.87 sine 106.52 minus 7.53 cos 53.26 minus 1.5 sine 53.26. Okay, so if we put these values, sine 106.52, I hope you guys are knowing how to calculate these values. Okay, 7.53 cos 53.26 and sine 253.26. So when we calculate all this, it comes as plus 3.76 minutes. Again, I'm repeating this equation of time, this formula sheet I'll share. This equation of time is A cos 2 pi n minus 1 over 365 plus B sine 2 pi n minus 1 over 365 plus C cos 4 pi n minus 1 over 365. Generally we consider the top 3 coefficients which are there, or the 4 coefficients, putting the value of A, B and C, D, and then calculating the value of V, the B value that we have calculated, that is there. This is 360 over 365 n minus 81. The number of days are 135, so 135 minus 81. From here we calculated B, which is put it here directly. Okay, and then the sine 2B, cos B and sine B. This is the value 106.52, 53.26 and 53.26. So we know that these value calculation, and then we calculated it, and the equation of time is plus 3.76 minutes. Again I'm repeating, we have the formula, we have the coefficients. Generally we consider the 3 starting coefficients. This is positive, this is negative because of this formula. If you are not getting confused, let me show you. You can be confused also, right? Okay, this 2 pi, 4 pi and minus 1, 365. So if in D figure you are putting these values, C figure you are putting these values, and you are calculating it, no, then this will come. And when this will come, you can put the values directly and then you can calculate it. Okay, is it clear?
Yes, it's clear.
Okay, still if you have any doubt, you tell me. I have certain other numericals of this type. I can send you, you can calculate it. It is just a formula based question, where in the EOT you have sine term, you have a cos term. You have to calculate the sine and cosine of them, okay, using the tables, and if not you can use the calculator also. And generally we use the 3 coefficients, and we calculate the B, and we calculated the number of days till May 15th, and then we put it the value, we put it the sine and cosine, and this EOT we calculated. And this, let me tell you, this is just like, it's not a fun fact is this, it's not like that, the equation of time, that the time that you are calculating is the exact time. Like, every formula has some loopholes and there are many coefficients, and this formula is even more extended, but we are considering the first 3 or 4 terms only to you have a guess what could be the possible nearby value of equation of time at that particular latitude or longitude, orientation. So yeah, the exact time may differ plus minus zero point 0.5, but yeah, we can guess a value that, yeah, plus 3.36 plus 3.5 minutes, it could be the particular EOT at this particular hemisphere. Okay, so it's not like that this is the exact value, but yeah, we have some idea, but all these equations are man-made and we cannot just predict that values very well, but yeah, it is there. Okay, let's move to the next question. The
Hello,
fifth,
sir.
yeah,
Sir, my name is Tanbir and I'm from a mechanical background.
okay.
And sir, as I have very little knowledge of semiconductors, do I need to enroll a course, enroll another course in semiconductor, or I will learn everything from here, this course only?
Okay, fine. Did you join the class late, Tanmay?
No, no.
Okay, so I'm repeating myself. So, like Sir has divided this course into 8 weeks. Okay, and the week one class is generally telling you about the fundamental aspects and the geometrical relations and how you are measuring these time zones and that time zones. That means the first week course is just to give you, a output, like how this sun, this ball of sun is, is a massive ball of energy, is playing role. But let's come to reality, and for our understanding, yes, definitely there will be classes related to semiconductors. A week 2 class is for the semiconductors, where sir will be telling you about the semiconductors, the band gaps, direct band gap, indirect band gap, their electrical characterization, everything. Okay, so I don't think you may have to go for another course, because week 2 class itself will be more sufficient to give you an idea and overlay of the semiconductors. Okay.
Okay, sir.
Okay, and still, if you think that you have some doubt as you from the mechanical background, let me tell you, I'm from an industrial chemistry background, so I can share you some books, and you're always free to email me. You're always free to email me if you have any doubt regarding it, and I can give you short notes of around 15 to 20 pages, or a review paper which is telling all the basics of a semiconductor, like how these Venn diagrams come, and what is a Fermi level energy, and how many different types of semiconductors are there, like the junctions, the PN junction, the N junction, all these things I can tell you.
Okay, sir. Thank you, sir.
Okay, my YouTube channel link. Okay, just a minute. I have to interrupt to you people. I need to share you my YouTube channel. So I have not known. I'm sorry for this interruption. Ah, about. Yeah, okay. So this is my YouTube channel link. Krishna. Okay, so let's move further to the fifth question. The fifth question is saying which of the following are considered for the equation of time correction in the solar time equation. The options are latitude and longitude of the location, eccentricity of Earth's orbit, daylight saving, and axial tilt of the Earth. And you have 1 minute to give the options, like the answers. What could be the possible answer of this question? You can type in the chat box.
It is C and D. So sorry, D. Axial tilt of the Earth.
Great. Why do you think the answer could be C?
No, no, it's D. D.
Okay. I mean,
Eccentricity. Yeah.
Actually, it has two answers: eccentricity of the Earth orbit and axial tilt of the Earth.
good.
Both are saying.
Who is this? Who is this?
Abin.
Happy. Good, good, good. Why it can't be latitude and longitude? What do you think? Like C is eliminated. That is very straight. And the answer could be B very straightforwardly. And D is right. D could be also an answer, D could not be. But why cannot be the latitude and the longitude? Anyone? Okay, no issues. Let's go to answer. Who is trying to animate now? Malay. Malay D. Suraj is saying B and C. Vinayak is saying B. Acha, those who are saying C, why do you think the C could be the answer? The daylight saving. Suraj, were you confused? Okay, okay. So the right answer is B and D, definitely. You know, equation of time is very much free of this latitudinal and longitudinal portions. Can you see anywhere in the formula where they are putting the latitude and longitudinal portions? Nowhere. They are just considering this number of days and this length of time. Okay, and we have the coefficients, and the coefficients are being calculated. Okay, so the equation of time is itself free of the latitude and the longitudinal location of a place. Okay, so the correct answers are the eccentricity of Earth's orbit. Definitely, it is a very major factor, and the axial tilt of the Earth. This is why the equation of time were considered for this solar time equation. Okay, this is right. Okay, let's move to the next question. Question number 6 is saying the solar radiation intensity in watt per meter square that is incident on an object is given as. The options are H naught is equals to R sun square over D cross H sun. Uh, H naught is equals to R sun over D square cross H sun. H naught is equals to R sun over D whole square cross H sun. And D is H naught equals to R sun over D cross H sun square. And you have 2 minutes to tell the answer. It's
Sir, C
360.
option.
C. Okay. Let me see how many of you can guess it. I'm just trying to see the presence of you all. Like you're just not opening up the lecture and just put it the phone somewhere nearby. Because when I used to take the online class, I used to do it. So I need to check that you guys are present there or not. Or I'm just talking in the air.
Sir, what was the answer of question number 5?
Yeah, B and D. Oh, sorry. The answer of question number 5 was B and D. I showed you, no? B and D. I'll share these, okay? This PDF I'll share with you people. B and D.
Sir, the sixth answer is C.
Sixth answer is C, you think? Okay. Others? Abin is saying C. Melody is saying C. Malay, I'm pronunciating your name right? Suraj is saying C. Okay. Great. Fine. So let's see. Actually, if you guys figure out the problem, this was what sir taught in the class, right? Okay. So
Sir thought that it is a D square is there, R square by D square
yeah,
into H sun.
yeah. R square by D square sir told.
Yeah. So I thought, sir, teaching class is like r square by d square in the HSM.
In the
In and the HSM.
yeah. So like what are the Sn? The Sn is the power density. Okay, R is the radiation and D is the distance between Sun and Earth. And the H naught of Earth is 1366.1 watt per meter square. Just for the sake, remember this value because I have made a question after that which is based on this. So you guys answer is right. The answer is C. R Sun over D whole square cross S Sun. Because I have made, if you put this in the single square, that means this will become like this. Right? Right, Ashish? So the answer is C, right? I'm not wrong, I guess.
Yeah.
Okay. Okay, so let's move further. The next question is 7. 7 is saying the distance of Mercury from Earth is 5.7 cross 10 raised to 7 kilometers. Okay, so the nearest value of solar constant will be. This is a very straightforward question, people. If you can find out. Anyone? Okay, you people know that this H naught is calculated on the basis of the distance in between Earth and Sun, and the value of H naught of Earth is 1366.1 watt per meter square, right? And the distance of Mercury from Sun is given, from Earth is given, right? So, if we know the H naught of Earth, then we can calculate the H naught of Mercury, right?
Yes, sir.
I'm giving you 2 more minutes.
Sir, the question is not visible.
Oh, sorry. Yeah, this is there.
हो गया मेरी पढ़ाई का टाइम
By the way, it's a very straightforward question. If you can see the relation between H naught and D square, and how it is related, and then how this D plays the role. Okay, you know the value of Earth. Okay, and you put on the same equation you put for Mercury, and then eliminate other options. And to be straightforwardly, if I say that you know the rough value of Earth, and you know this order of magnitude is 10 raised to 7, okay, and this is 5.7 also there. So if you, this order of magnitude is given 7. Okay, so one thing is sure, that the value of H naught of Mercury will be nearby in between 6 to 7 times of the value of Earth. Now we know, we just have a look, that the value of Earth was 1366.1. So if we make 6 or 7 times of this, that means it will come around 9000 something. In the options, we nowhere have any value which is having 9000 except option A, right? So the feasible option is 9116.4 watt per meter square. Like, it was just a linguistic question. If you see, like, we know na, that 2 pence cost this, and somebody has bought 7 pence, then what could be the cost of like this and this. Like, we know the general aptitude questions we do. So this was just a straightforward general aptitude question. What we have to figure out here, okay, let me repeat. We know the relation in between H naught and D, where D is the distance between Earth and Sun, okay, in meters. Remember, in meters, and that was in kilometers. Change the value, the order was 10:7, it will become 9, and then this is inversely proportional to D squared, that will cancel out, then again it will become 7. Okay, that means somewhere the H naught for Mercury will be nearby in between 6.5 to 7 times of the value of Earth. Now we have to have a look over the options. Nowhere in the option in BCD is showing the value which is near to 9000 something except option A. So the option will be A directly. Although I have taken this question from the values, but the option is A. The right answer is A. Am I clear? Am I clear or not?
Yes, sir.
Again, I'm repeating, you have to have a look over this, the H naught relation with D square, okay, and this is a common term, right, in both of them, and then H naught of Mercury we need to calculate. This is like this, then we see the order of magnitude, and the magnitude is 6 to 7 times, then somewhere the value of H naught of Mercury will be 6 to 7 times of this value, and the only option which is 6 to 7 times is this. That means the correct option is A. This was like a general aptitude question. I have just put it just for checking the understanding. Okay. Okay. Let's move to the question number 8.
So your answer given to the sixth question is wrong. It means you are writing the PDF.
I have put it, this question answer is wrong. I need to put this square the whole square. You're right.
Yeah.
You're right. I'll correct it up. Who is this?
Sabin.
Abhi, yeah, I'll do that. I know it. That is why I was trying to hide it, no? Because while typing I made this mistake, and then I thought that let me hide it from you. But you have got good observing skills.
That's why I already correct you in previous time.
Okay. Okay, the question number 8 is which amongst the following statements are right about the radiant power density? So the radiant power density, also known as radiant flux density, this is a theoretical question. Like, okay, it could be a possibility that you may know it, you may not know it. If you don't know it, then you go through the solution that I'll tell you, and you will come to know about it. Probably sir have not told everything about it, but in order to omit the confusion with other terms or other streams, because those who work in solar or physics, they use this term confusingly for some other purposes. So your confusion should not be there. That's why I put it this question. The question is saying, which amongst the following statements are right about the radiant power density? The options are, radiant power density, also known as a radiant flux density, is the power per unit area of light either emitted by an object or received on a surface. We use, the B option is saying we use the idea of radiant power density to describe the spectrum of light radiated by a given object, as well as the spectrum of light that reaches a surface, which is absolutely right. Okay, the third is the irradiance. The intensity of irradiance is also confusingly called the radiant flux power or density. So, do you know about this C option? Did sir say anything about the C option?
Sir, explain about the solar irradiance. That's all. More than.
So it is same like the solar irradiance. Can we call it power density? We call it flux. That is clear. Okay. Without further delaying, because this is a very theoretical question, and you may know it, you may not know it, because I also didn't know it much. I was actually going through. There are certain points that we need to clear out because I myself got confused about it once. So the radiant power density is also known as radiant flux density. It is a power per unit area of light either emitted by an object or received on a surface, and it is determined by both the photon flux, that is the number of photons passing through a given area in a given time, and the number of photons for each given wavelength energy taken into account in spectral irradiance. The intensity of irradiance is also confusingly called radiant flux or power density, where but in solar physics usually it refers to the light received on a surface at some distance from the source. So we know that the irradiance is also defined as a power per unit area. So the intensity or irradiance, we also call them power density confusingly. But in solar physics, it refers to the light received on a surface at a distance from the sun. So this is the confusion between the solar physics and the terminology that we use. The third point is to clear it out further. The radiant emittance or a radiant excitance is specifically the radiant flux power density emitted by an object or the intensity of light at the source. Thus, when when we speak of radiant power density in solar applications, we are probably referring to the power density incident to our Earth's surface that comes from the sun. That means the term that we use for radiant power density is right. Like if we are using flux power density or irradiance as radiant power density term, that means we can swappingly or conversely use radiant power density as power density or a radiant flux. All these three are more or less same terms, okay, but in solar physics it have a different spectrum, so do not confuse them. We use all of them together, okay. So the answer is all of them.
Sir, can you explain in one line what is the solar power, radiant power density?
What is the
So, radiant power density.
okay, this if I say about the irradiance, no, like if I talk about the power density, who is this?
Sir, again, Abhi.
Abi. So let me take you this way, in a very layman language. You know, we have you heard about this flow cell or this supercapacitor or battery? Do you know anything about them?
Yeah, super
Yeah, okay.
capacitor. I know.
So we have a term called power density there. Okay, and the the how should I say it? The efficiency of these batteries or this supercapacitor generally used to store energy. Okay, so capacitance. Okay, so they are defined in terms of power density. Okay, now this power density term that we are using or the radiant power density term that we are using, some people confuse it with the solar physics power density term. There it is somewhere different from us, but we get confused. What in solar term it is defined as, like, let me read this for you. In the solar terms, this is defined as uh, uh, light received on a surface at some distance from the surface. So irradiance is also the power per unit area. Okay, so that means we can use this term, the power density. Density means, like, density is not like that mass per unit volume. Density means in a specific area how much power you can generate, right? So we are using this term confusingly in solar physics also, but they both are more or less same term. There it has a different meaning, here it has a different meaning. Here we are generally confined or generally concerned with the irradiance relation with the flux or the power density. Okay, but this power density term is also used in solar. The power density term is also used in supercapacitor. The power density term is also used in batteries. But the essence of that power density term is different from the essence of the radiant power density term that we are using. We are concerned with this solar physics power density term where some energy is getting consumed, some is getting radiated. So how we are calculating that radiating energy and the consuming energy, we are using a term called power density, that is radiant power density. Are you getting me what I'm saying?
Yeah, okay. I got it.
And if you have
Thank
any
you.
confusion, you can mail me, right?
Yeah, okay, thank you.
Okay. So let's go to question number 9. You have got 3 minutes to answer this question. It's 4:08. I'm giving you time till 4:12. Uh, what is the correct matching of this? We have talked about this many times, but this is just shown in a different layout. And I have put it some different values like theta, gamma c, and beta c. Theta is this, gamma c is this, and beta c is this. This is Janet, this is a normal aperture, they are the poles, and this is the sun's light coming in. Perpendicular is this, and here it is how it is reflecting. Abir, let me show you, like just to clarify you more. They are the coin cells, okay? And then we calculate the power density in these coin cells. And then we tell the efficiency of our battery, like what is actual efficiency that we could get out of, combining them in series or combining them in like parallel views. What is the power output we are getting? What is the current we are getting? There it is the power density, which is a different term. So we don't need to confuse it.
Okay.
Option is
Hmm?
sir A option.
A. Okay. Others? Who is this?
Sir Suraj.
Suraj. Okay. Abir, what is the answer? Abir and the other guy, what was his name? Suraj, Vinayak, Tanveer, Malay. What are the answer? Ashish.
Yeah, we couldn't see the screen.
Just a minute, I'm sharing you again. I was just naming you people. This is the screen. Somebody is trying to join. So late. Oh, answer. See, let me minimize it so that you can see it.
Sir, it is not visible. It is small
It is
size.
not
Yeah,
visible.
it's not visible.
It's not visible?
Yeah, it is small in size.
Okay.
Yeah, now it's okay.
You type in the chat box your answer, then I'll check out. Acha, sir have told you about the books, right? The reading materials?
Yeah.
Okay. So you guys are following which book? Like, have you downloaded any book?
Not yet. Not yet.
Yeah, the
You done?
answer is third number.
Okay. Other people? Rajiv. Okay. You can go. I'll share the solution. Don't worry. And if you have doubt, you mail me. Malay saying okay. Answer is 3. Rajiv is saying 3. Abin is saying 3. Suraj is saying A. Just try to look it from a different angle. I have just tried to change the layout of looking. The figure that Shar has shown you and you generally see it is a little different than that. And I've tried to change the notation so that your doubt in between azimuth, tilt and incidence should clear out. Let me tell you guys, like those who are interested in doing research in this field, uh, you know what, like a lot of research nowadays is going on perovskite solar cell. So I will be telling you about the perovskite materials in week 8, which is the new material. Like there are different dimensions of these material. We have 3D perovskite, 2D perovskite, 1D perovskite, and generally we are utilizing these materials for the application of solar cells and photodetectors and LEDs. Okay, now why these materials are important? These materials are important because we can play with their band gap. We can dope some element in them, we can extract some element in them, we can create vacancies, we can change dimensions, we can and changing all these parameters change their optoelectronic and photophysical properties. Like they change their absorption, they change their emission. Suppose you create a vacancy, some material was giving a emission in yellow region, it start emitting in orange region, and you can utilize it for certain of your applications, and the whole electron carrier dynamics change. So like these materials are getting sold nowadays very much. When sir will be telling you about the solar cell, try to learn about the perovskite solar cell as much as you can, because this is a major area in which the research is going on nowadays. Okay, so without delaying further, let's go to the answer of this question. So this is the third question which was seen. Okay, let me show you this figure. I've taken this figure from an English author book. If I summarize this radiation on a fixed surface where ITH is IB cos theta z plus IDH, theta is this, epsilon cos is this, where this is a horizontal irradiance, this is a beam irradiance, and this is a diffuse horizontal irradiance, and I see the surface normal irradiance. Okay, remove this, I'll share this video. You should know all these equations also. If we talk about this figure, so theta is a surface incidence angle. It is very clear, it is incident on this surface, it is the normal aperture. If you take the angle in between them, this is what a surface incidence angle is. Okay, and gamma c is the azimuth angle. We know what is azimuth angle, I have already explained. And beta c is the surface tilt angle. If you see this zenith, this perpendicular surface, and if you see this gamma, you see this and this structure, this angle in between the zenith and the aperture should be the surface tilt angle. So this is the tilting angle. So theta is again surface incidence angle, because this is directly indicating the incidence, and this is the aperture normal. The angle in between the incident and the aperture normal is the surface incidence angle, and then we know we make a perpendicular from there and make a straight line, and then this straight line and this perpendicular, the angle in between them is the azimuth angle, and then this is the angle between zenith and aperture normal is a tilt angle. This is a tilting in between the normal, the perpendicular line and the aperture that we are considering. This is the surface tilt angle. So theta is a surface incidence angle, that means first is B, and then gamma c is the surface azimuth angle, that means first is B, second is What? Theta is a surface incidence angle, gamma C is a surface azimuth angle, second is A, and third is B. First is C, second is A, third is B. That means the option is what?
3.
Yeah, right. Okay. Have I not made a mistake in explaining? I think I have put it the answer wrong of this question also. I correct in the assignment. But yeah, the answer is C. I put it this figure. Actually, all these questions I'm making brand new for you. So while typing, I'm making some mistakes. A, B, C is getting shifted here and there. Okay, so the last question of today's discussion class is the hour angle is 3:30 p.m. is, and the options are 52.5 degrees, 5.25 degrees, minus 52.5 degrees, and minus 5.25 degrees. And you have got 5 minutes to tell the answer of this question. Just let me give a check if the recording is going on or not. Okay, Melee is saying option C. No, Melee, you're very much active on the chats. Good. Others, try to do this question. Anyone? Can you answer? Can you solve this question? Sudas saying C, minus 52.5 degrees.
Plus 52.5, I think.
Okay. I mean, I have not told that. Like I have mentioned it's PM, 3:30 p.m., not 3:30 a.m. Right? PM means afternoon. You see the clock. The clock is going like this. That is for what the question is. If I'll tell the answer directly, then the confusion is A and C, right? Okay, without delaying further, let's see the solution. The answer is A, 52.5 degrees. And PM, generally the sun is on the right side, so we consider positive. So the formula is in the local LST format, H is equals to 15 degree LST minus 12. In the above equation, we can convert the LST in hours to LST in minutes. So in minutes, if we consider H equal to 15 degree into LST in minutes over 60 minus 12, this is the actual formula. Using the above formula, we can quickly calculate the solar hour angle uh, at 3:30 p.m.
Sir, can you zoom it? It is not visible.
It's not visible?
Yeah.
Okay. So using the above formula, we can quickly calculate the solar hour angle for any time. For example, at 3:30 p.m., H is equals to 15 degree cross 15.5 minus 12. That means 52.5 degree. This 15.5 will be a negative value if it is a AM. But this is just a rough estimate. This is not a correct value. The correct answer is 52.5 degree, no doubt. That is the option A. But if it would have been 3:30 AM, then it would have been minus 52.5 degrees. It is just like the 24-hour format of a clock. What is the positive side and what is the negative side? Generally, like the right side is calculated, considered as a positive side. So it is 52.5 degree plus. Is it clear, Mele? Yeah, okay. Okay. So Ashish, Abin, uh, Gaurav, Stephen, Mele, Suraj, Tanveer and Vinayak. What I'll do, I'll share this PDF merge with the uh, PDF of the presentation of the questions along with the solutions in the drive. I'll share that drive with you people, or in the portal where it need to be uploaded. And I have already shared my YouTube channel link with you guys, I guess. And if you have not, if those who have not received it, I'm sharing it once again. I'll upload the recording of this video once again there. You all have my email ID. You can email me anytime if you have any doubt. Can anyone just share my YouTube channel link again here? Like, I have to open and copy it again. I shared in the chats, right?
Yeah, it is there already.
Yeah, so take it from there and follow the channel until the course is there. I'm not, this is my very first time I'm making a channel like on YouTube and sharing all these videos. So pardon me if there is some mistake. And thank you, Abin. Thank you. So I'll upload the recording of this video on the YouTube channel, and you can see there, and you can email me anytime you want if you have any query. And my email ID is like this. You can have a look over here. The details are like this. So every week I will be giving an assignment on the basis of a week classes, and generally my class will be on Saturday from 3 to 5 p.m. most of the time. And I am from either Kolkata, once again I'm telling you, and I am a TA of your course. And along with me, two more TAs are there. One is Ravi and one is Hari Shankar. Ravi has already taken a class of few people, I think, before me, the last day. And the next very day, there will be a class taken by Hari Shankar. So we all three people, our duty is to clear your doubts and help you in solving assignment. Like, we will try to solve some questions which are somewhere related to the assignment, which can help you in solving assignment and can guide you to solve the problems and answer the questions if you're taking the exam of this certification course. So I hope I was able to clear some of your doubts and tell you some new information in this first class. Although I'm not using iPad, but from second or third week I will be using iPad. But initially I'm just using these slides and solutions. Again, I have shared my YouTube channel already with you. I'll share these slides and my email ID is written here. You are always free to email me and you'll get a reply to a question within 24 hours. And I guess that's all for the day. So if you guys have no questions, should we stop today's class? People, what do you say? Gaurav, Suraj.
Yes, sir.
Yes, yes.
Oh, Google Drive link. I mean, I have not created a folder till now, but I'll share these drive. You guys, yeah, definitely I'll share the PDF of solution, Vinayak.
Sir, attach the drive link and the PDF on the YouTube video, sir, in the description.
Okay, okay, yeah, okay. There I'll do, and I mean, you have this group, no? Like this email you receive, this email comes all together to you people. In that email, I'll share the drive link. I create a
Okay.
drive. I mean, the drive. I make a folder. I'll upload the assignment, and then I'll share it with you. Like I'll send by the email in a whole group. Like this email that you get, no? If I show you this email. So this email has this all the people noc 23.mm10.announce. So you receive all the people who are enrolled here receive the email that is being sent to this email id. Okay.
Yes, yes.
So I will send a drive, my drive link here. You will receive my drive link and my YouTube channel link, both I'll share once again. Once I get the recording and once I make the drive and share the PDF there, I'll share with video all. Okay.
Okay.
Yes, sir.
Okay then. See you. Uh, I hope this class was some informative, and I'll try to improve if there is some loophole, and get good learning, get good science, and try to use make use of this course as much as you can. If you have love for science, trust me, this is a very burning area. So try to learn as much as you can, because if I would have been at your place, I would have made full use of these things. Just don't try to understand. Like, I have a suggestion for you people. Don't try to understand everything. I mean, you may be able to understand everything, but if you're not able to understand a bit part of it, like in the next classes, don't be demotivated, because this course is generally going like this. So in the week 5, 6, 7 classes, you may see certain things which may be of your standard, which may not be of your standard. But if you are getting to learn to know about it, that if you are getting to learn about that there is something like perovskite solar cell, what is the architecture, what is NIP, what is PIN, what is a whole transport layer, what is the electron transport layer, that will be really advantageous for you in doing future research, in understanding the different domains of this field. So this is the basic target of this course. So have good learning, have a good remaining day, and let's meet the next very week. Okay then, see you. Tata, bye.
Okay, sir.
Thank
Bye.
you. Thank you. Bye.
Thank you, sir.